Here for you is the easiest way that I've ever found to graph parabolas. It's a two-step process where all you have to do is find the vertex of the parabola and then use a step pattern to generate more points. The step pattern you're going to memorize for parabolas is 1, 3, 5, 7, and you're going to have to multiply it by any number that's in front of your x squared. I'll show you what that means in just a little bit. If you're asked to graph this, you need to find the vertex, and we can read the vertex directly off of this because it's in vertex form. The vertex of this turns out to be at -4, because we flip the sign in here, and -4. -4, -4. And the number out in front is just 1. So it's 1, 3, 5, 7 for the step pattern. And here's what that means. If you take a look at my ultra sophisticated graph paper here, the vertex is at -4, -4. Let me put a point there. There's my vertex. And now the step pattern, 1, 3, 5, 7, means you go over 1, up 1, over 1, up 1, over 1, up 3, over 1, up 1, 2, 3 from that new point, over 1, up 5, over 1, up 1, 2, 3, 4, 5. And you do this in both directions. So you go over 1, up 1, over 1, up 3, over 1, up 5. And then just draw a line through all those points. And you have the parabola. Over 1, up 1, over 1, up 3, over 1, up 5. And if you had room, we could go over 1, up 7, up 9, etc. You could be asked to graph slightly more complicated things, like -x² minus 2x minus 1. Again, all you have to do is find the vertex, then use the step pattern. Now, my way to find the vertex is to use -b over 2a, which in this case is -2. This is b in front of your x, over 2 times a. A here is -1. This gives me 2 divided by -2. It turns out to be -1. That's the x-coordinate of the vertex. Then we plug that back into the equation, -1 squared minus 2 times -1 minus 1. See, we just plugged in -1 everywhere there was x. Calculate this. You can use a calculator if you want. I get -1 plus 2 minus 1. Oh, I get 0. Well, that was cool. So my vertex is at -1 and 0. See? X and then y. But my step pattern, which is normally 1, 3, 5, 7, we have to multiply by the number in front of x squared. -1, -3, -5, -7, and on and on. Let me show you how that manifests itself. What that means is that we have our vertex at -1 and 0. That's here, -1 and 0. Then we use a step pattern, -1, -3, -5, -7. And so we go over 1, down 1, because it's negative. Over 1, down 3. Over 1, down 5. Now I don't have room for that, but that's life. Over 1, down 1. Over 1, down 3. And keep going as much as you can. Then draw a line through those, or draw a curve, I guess I should say, through those points. And you have your parabola with the vertex at -1, 0. And it goes over 1, down 1, over 1, down 3, over 1, down 5. And on. Let's do this last one. 2x minus 5 minus 7. Now this is also written in one of those nice forms for us, where we can read the vertex directly off of it. +5, -7. Flip the sign in here, keep that as it is. And we normally have our step pattern of 1, 3, 5, 7, but we have to multiply it by whatever is in front of your x squared, 2. So your step pattern becomes 2, 6, 10, 14. See, we multiplied each of those by 2. Another way to think of this is that normally you go over 1, up 1, over 1, up 3, but the parabola has been stretched vertically by 2. So instead of going up 1, you got to go up by 2. Instead of going up by 3, you got to go up 6. Let's graph that. Vertex at 5, -7. 5, -7 is way down here. And the step pattern, over 1, up 2. 1, up 2. Over 1, up 6. 1, 2, 3, 4, 5, 6. Over 1, up 10. That's not going to fit. Over 1, up 2. Over 1, up 6. Use your step pattern. Draw a curve through those. This is not going to be the nicest curve. Here we go. And you'll see that as long as we can start at the vertex and then use this step pattern stretched or flipped as necessary according to whatever's in front of the x squared, be it 1, -1, +2. Just multiply your step pattern 1, 3, 5, 7 by that to generate more points. Over 1, up 1, over 1, up 3, over 1, up 5, times that number that's in front. 1, 2, you get it.